You may or may not want your formula sheet out. You may remember these from last year because we used them a lot, but this is the equations that we're going to be using for the remainder of this unit. In theory, this is review. Nate, we started out last year, I defined acceleration, and I defined it as a change in velocity over a given time. In math notation, I wrote A equals delta V over delta T. Good yawn, Nate. Good to see you're thrilled with this. Although since change, what is change in anything? Which I happen to write there for those of you who are paying attention. Since change in anything is always final minus initial, we could actually write it as A equals V final minus V initial over T. We get a bit sloppy, Alex, with our delta T because time is always a change in. Over the years, we've just stopped putting the delta in front of the T because it's always, for Pete's sakes, it's a change in. This year, for all of you, I have to be a little fussier. Let's just emphasize this is a vector equation. I could also find an acceleration by subtracting two vectors. How would I subtract two vectors? Oh, I wouldn't. I'd add the opposite. However, if I take the time to get the VF by itself, if I times the T over and plus the VI over, we got this one from last year, which we flogged to death. VF equals VI plus AT. Little note here, Sarah, this assumes a uniform or unchanging acceleration or an average acceleration. If we have a changing acceleration, you really need calculus at that point, otherwise the math gets a little ugly. We'll talk about situations where you would have a changing acceleration later on this year. The next equation is on your formula sheet, although you'll almost never use it. We need it to derive other ones. We need to talk about average velocity. If we have uniform or unchanging acceleration, we can find the average speed. Now, V average, the symbol for average is a, don't write that down. It's a horizontal line. The problem is when I photocopy and shrink everything down, it's very difficult, Max, to tell the difference between that and that, which is the vector symbol. So I will typically write V average. What did I put on your formula sheet, Zach? Did I go V horizontal line or did I write V average? It's going to be the top bunch there. Yeah, formula sheet, top bunch. Did I go V average or did I go V? Yeah, okay. Okay. How do I find the average? Well, Elliot, if I got $10 and you have $20, what do we average between us? How do you calculate that? Add them up and divide by? How can you turn a 10 and a 20 into a 15? Add them up, 30, and then divide by? 2. Yeah, 2. How to find the average of any two objects. So V average, and it is a vector, is going to be V final plus V initial divided by 2. I put that on your formula sheet. I think if you do that big ultimate review that I handed out last day, I think only once do you actually need to use that, but we need that to derive some other ones because, for what it's worth, for uniform acceleration, this average occurs exactly halfway between the minimum and maximum velocities. I'm not sure why these little boxes are coming in here. Well, I do know why, because this was typed in Word 2007, and I'm opening it now in Word 2016, so having issues. Distance is defined as V average times time. So what I'm going to do now, Marcus, is I'm going to drop the V average expression right into there. Oh, and since V final is V initial plus AT, I'm going to replace the V final with V initial plus AT. When I do that, I'm going to get as follows. D equals, instead of V final, I'll have V initial plus AT. And then there's still another V initial that drops down like a domino. And that's all over 2. And then outside the brackets, I have a T. Ooh, 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 cool. Look, I have like terms. What's 1 VI plus 1 VI? 2 VI. So if I hear you correctly, I don't think I do, you're telling me I can write this as, in brackets, 2 VIs plus AT. The T is still outside the brackets. All over 2. I'm going to multiply the T into the brackets. Chunk. When I do that, 2 VI times T is going to be 2 VIT plus AT times T. It's going to be A. What's a better way to write T times T? T squared. And it's this whole thing all over 2. Right around now, a lot of you are starting to see where we're going with this, what we're about to derive. That top fraction has 2 big terms, a 2 VIT and an AT squared. Since they're all being divided by 2, I can actually divide this up into 2 VIT over 2 and AT squared over 2. Why did I do that? Because in that first fraction, what can I do with that there 2 on the top and the 2 in the bottom? Yep. And I get D equals VIT. Hey, that sounds familiar. Plus AT squared over 2. Although we never said AT squared over 2. Dividing by 2 is the same as multiplying by which fraction? By which fraction? That's why we wrote out D equals VIT plus a half AT squared. But there is the derivation. I will not make you derive this, but I'm enough of a nerd that I like to show you where it came from. So in the box on the next page, we can write D vector equals VI vector T scalar plus 1/2 A vector T squared. Ta-da! You awake now, Charbel? Come on! I tried to warn you, and I get the graphic, and wow, big font. There was a fourth equation, the one with the squared in it. Remember that one? I think VF squared equals VI squared plus, remember that one? Okay. Start again with distance being defined as average speed times time. Again, I'm going to plug in V average being V final plus V initial over 2. But I'm going to write time, since VF equals VI plus AT. I'm going to get the T by itself and write time as VF minus VI over A. I'm going to get a pretty ugly looking expression. Looks like this. D equals, there's going to be 2 great big fractions. The first fraction is going to be VF plus VI over 2, and the second fraction is going to be VF minus VI over A. Harshpreet, is this one fraction?
So yes.
Is this another fraction?
So yes.
What's the mathematical operation happening right there? When you have 2 brackets side by side with nothing in between them?
Same
Multiplying. What's the rule for multiplying fractions? That's the easiest one. Multiplying fractions is very simple. Top times top, bottom times bottom. No cross, no, not just top times top, bottom times bottom. In fact, Harshpreet, we're going to do the bottom together. 2 times A. Now on the top, you're going to have VF plus VI in brackets and VF minus VI in brackets. Hey, you may have recalled that's a binomial times a binomial, if I use your math terms, where you had to do this FOIL acronym. Yeah. So I'm going to go D equals, there's going to be a big 2A on the bottom. Yay. I'm going to go VF times VF. What is VF times VF?
Yes, word.
Yep. I think Elliot just kind of saw where we're about to end up at. Saw your eyes kind of, I see where he's going. Then, Harshpreet, we're going to have a VF times a negative VI. I'm going to get, remember this, negative VI VF. Just remember that. When I multiply those two, I'm going to get a positive VF times V. I'm going to get a positive VIVF. What's negative VIVF plus VIVF? Nothing. I like that. And then I'm going to have a positive VI times a negative VI. First of all, what's a positive times a negative? And what's a VI times a VI? Yes? And now if we get the VF squared by itself, wouldn't we times the 2A over? And then plus the VI squared over? And I think if we did that, the D would stay where it was. I would times the 2A over. I would plus the VI squared over. And that would leave me with the VF squared by itself. There. Are you ready? Ta-da! Let's put it in the box on the next page. VF squared equals VI squared plus 2AD. Now, there are some teachers that don't teach this because it's a bit strange. The vector bar goes on the A and on the D. The problem is on the VI squared and the VF squared, when you squared things, you might recall from last year, sometimes you lost a vector. Sometimes, especially if you squared a negative, you ended up with a positive, and even though you wanted your final answer to be negative, this one, you always have to look at your final answer and just double check, does the direction match what I expected it to be, or am I going to have to insert an extra negative? You might recall in particular if we were in free fall and we wanted to find out our impact velocity, if we used this equation, we got a positive answer, and then we said, well, we know we're going down, we'll just insert the negative in front of our V final. To solve a problem, remember DFIC. What? Alex, my friend, I have two main acronyms that I use when I teach. One I already showed you. Who remembers? Don't write this down. What does DULP stand for? Draw a little picture. When in doubt, DULP. Draw a little picture. The other acronym, and this is only a starting point. Most of us have moved well beyond that, but just to jog our memory, is this acronym called DFIC. And that stood for, if you're not sure what to do, start out by listing your data. What do they tell you? Then try and find a formula that has some or all of your data in it. Carefully insert the numbers and then calculate the answer. Really, Zach, that's not that great an approach for advanced stuff, but for last year in Physics 11, when we were starting out kind of plug and chuggish, it gave you a hook to hang your hat on, and most of you actually stopped doing it because you could kind of say, oh, I know exactly where I'm going. But I already told you, I think yesterday, last class, that I will be giving you one question on every test that you've never seen before. When I come to those ones, I DFIC and I DULP, and that's part of my strategy. There's others as well, but that's part of my strategy. So, let's run through some numbers. A dragster has an acceleration of 38 meters per second squared. It begins from rest. How fast will the dragster be going after 2.1 seconds? The word or the phrase from rest I taught you last year is worth either underlining physically or Krisha, at least make sure you noticed it. Ding, 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 ding. Krisha, my joy, what are they asking me to find in part A? Which variable is how fast from my 4 kinematics equations that we just derived? Which velocity, initial or final? Okay, right? All coming back to you. VF equals question mark. Alex, could you shut that door for me there? Youngjun, could you shut that door for me? Thank you. Then I go back and I list my data. What's that 38? What's that 38? How do I know? I told you it was worth memorizing. As much as I hate memorizing stuff, it's really worth memorizing units. So I know this is an acceleration. Is that big? Who remembers, what was 1 g of acceleration worth from last year? 9.8, really close to 10. This is about 4 g's. This is legitimate. What about the dragster guys when they floor it, pull for a split second? From rest. Krisha, what's that tell me? Ah, there you go. T. 2.1. I really should have said 2.1, and you should have said T time. I flipped them already. I'm looking for an equation that has a VF and A, a VI, and a T in it. There is one. Which one? Yeah.
VF equals VI plus AT.
This year, Zach read too much. Last year, I was fine with that. This year, he did extra work. It's not VF equals VI plus AT.
VF equals AT.
Okay? And I'm going to encourage you, start noticing the modified equations on the fly. I'll never take marks off, but let's be clever and lazy, right? Why no VI? Because VI is 0. Well, if it's 0, don't need to write it. A is 38. T is 2.1. I can do this in my head. 38 times 2 is going to be 76. 38 times 0.1 is 3.8. 76 plus 3, 79.8. Double check me. Yeah? Krisha, units? Direction. Well, did I give you a north, east, south or anything in this question here? Then we'll fall back on last year. It's implied to be positive and forwards. I won't make you write a direction here. I've watched enough drag races to know they tend to go forwards. Although it might be more interesting. Anyways, they tend to go forwards. B. Michaela, what's B want me to find? Is it the same time frame as in part A? Is it the same time value as in part A? Then I'm not going to re-defic everything. If it had changed, I'd relist my data because I want to make sure I don't accidentally use stuff that's no longer valid. But since it's the same amount of time, I'll keep this on my screen, and I'm just going to go D equals question mark. I'm looking for an equation that's got to have a D in it. It'd be nice if it has an A, a VI, and a T. However, this year, you're going to find an awful lot of the time, Mike, you're going to have to use something that you've already calculated. You're going to have to use an answer to find another answer. I'm not going to avoid that the way I did in Physics 11. Any thoughts on which equation would work here?
T equals half AT squared.
Ah, Elliot picked up on my laziness. Why didn't he bother reading VIT? VI is 0. Now, I had somebody last block say D equals T plus a half AT squared. And I said, well, no. When you're multiplying by 0, that whole term vanishes. So we can just say, hey, D equals a half AT squared. 0.5, 38, 2.1 squared. 0.5, 38, 2.1 squared. It's going to be a little bit bigger than 80. Because 2.1 squared is really close to 4. Half of 4 is 2. It's going to be roughly 38 times 2. 83.8? Units, how far? Meters. I usually put a box around my answers. I'm inconsistent on that, and it's not a rule. But that's always, especially after a long question, I'll almost always put a box around it. That's my touchdown dance. Like that's, there's the answer. Ha-ha! Doris, what's part C asking me to find? Time. T equals question mark. And you know what? Since it's asking me to find time, we're no longer at 2.1 seconds. I'm going to relist my data, the stuff that I can use. Is VI still 0? Yeah. Is A still 38? Yeah. Is VF still 79.8? No, can't use that. Oh, what is VF here? Yeah. Darcy, I'm looking for an equation that has a T, a VI, an A, and a VF in it. There is one. Sorry? Can you get the T by itself, please? He said, Yep, so it would have been minus VI over A, but since VI is 0, we can even be lazier. I'll take that. Time, scalar or vector? Scalar. Positive or negative time, always. So built-in error check, if you ever get a negative, go check your directions, right? 126 divided by 38. It's going to be a little bigger than 3, because it's almost 120 divided by 4. 3.1? That's a guess. No?
3.32.
3.32? Okay. A little bigger than 3. I had that part. Round it off properly. Units, Darcy? There you go. Remember all this from last year? Although we spent like 3 weeks on this last year, and now we're getting it. Piece of cake. How far will the dragster have traveled once it hits 153 meters per second? What's this question asking me to find, Sydney? And I think we've changed the condition again because it says 153. So VF this time is 153, VI still 0, and A still 38. Sydney, can you give me an equation that has a D, a VF, a VI, and an A in it? And preferably get the D by itself, if you would be so kind. Yep. Although I would argue this time you read me too much. I probably could have just said, ha-ha, right? The modified equation is going to be VF squared over 2A. So it's going to be 153 squared all over 2 times 38. And I get 308. And that seems like a good ballpark figure to me as well, just on the few drag races I've watched on TV. 153 meters per second, that's right around a dragster's top speed, just shy of 300 miles an hour. They can go, like out on the salt flats, there are cars that have gone faster. They have actually broken the speed of sound, but I'm talking about the standard watching racing on TV dragsters. 308 meters. Good stretch, Nate? Feeling awake? Because you're up. E says this: when the dragster hits a top speed of 162 meters per second, the chute is deployed. If it takes 12 seconds for the dragster to come to a stop, what's its average acceleration? How long does it have to travel before it comes to a stop? Let's call this, Nate, part 1. Let's call this part 2. In fact, since there's 2 parts to this question, I'm going to be really clever. Ha-ha! Nate, my friend, what's the first thing they want me to find? Yep. Why did I say average acceleration? Again, this is me as a physics nerd hedging my bet. I'm willing to bet in this case, Christina, the acceleration is not uniform, isn't constant. In fact, I think when you pull your parachute, there's a much bigger jolt at the beginning than later on, but we can't handle a changing acceleration. So if you ever see me stick the word average in front of something, just find the acceleration and assume it's constant. It's probably not, and I'm hedging my bets. So A equals... What else do I know, Nate? What's that 162? Ooh, is not V final? Oh, no, what's V final? Okay. So V initial is 162. V final is 0. What's that 12? Now, I was a little sneaky. I wrote out the word seconds, and I even put it on the next line just to see who's paying attention. But sure, T equals 12. Looking for an equation that has an A, a VI, a VF, and a T in it, and preferably has the A by itself. Nate, which one, my friend? Give me the whole thing. Rewrite it, get the A by itself, but don't cross anything out. isn't it going to be VF minus VI? Yeah. And in this case, that's really important. Because, Nate, what's VF? 0 minus, what's VI? Divided by 12. Am I going to get a positive or a negative answer here? I'm going to get a negative. Is that going to make me nervous, or is that going to confirm that I've done this right? Nate, when I pull the parachute, am I speeding up or slowing down? So am I expecting a negative acceleration? In fact, the fact that I get a negative will probably confirm to me that I've set this up correctly. I'd be much more nervous if I got a positive acceleration here. What do you get? Negative what? 13.5? Units, Nate? Yeah. Nate, that's about a G1/2, which I think that's about right. When you pull the parachute, you do get thrown against your harness a little bit. But it's not like crazy amounts of acceleration, of deceleration. Okay. You all right with that, my friend? Cool. Max, what's part 2 asking me to find?
Time.
Yeah, I was a little sneaky because I said how long.
Distance.
Ooh, because how long can mean time or distance. Here in part C, how long meant time. In part E, am I asking time or distance? Why? How do you know? You're right. If I was asking you for the time, wouldn't you just say, duh, 12? And that would be a silly question because I gave you the time. Yes? Okay. So D equals question mark. Here's part 2. I'm not going to relist my data. Instead, I'm going to say, hey, is there an equation? Now, there is an equation that has a D, a VI, a VF, and a T. This is the one that we hardly ever used last year. This is the D equals 1/2 bracket VI plus VF times T. It's not on your formula sheet this year. You can use it if you remember it, but it's redundant. Instead, Max, we're going to use acceleration as well. We're going to use an answer to find an answer. Can you give me an equation that has a D and some of this stuff in it that I can use to find D? Absolutely, that'll work. I'm going to go with this one. Because isn't the D by itself already? I'd give you full marks for either, but I'm lazy enough to say, well, I don't have to rewrite this. Now, I'm so good at rewriting an equation in my head that really it's not a time saver to do it this way, but we can. What was VI, Max? T12 plus 0.5 negative 13.5 12 squared. This distance, am I expecting a positive or a negative answer? What do you think? Luke, what do you think? I'm pretty sure when you pull a parachute, which way are you still traveling? Absolutely positive. If I got a negative answer here, I'd be nervous, or this poor driver is not surviving, because that would somehow mean at almost 300 miles per hour, they suddenly jerked to a stop and started going backwards. We did last year, I showed you the video of, I think it was Colonel Stapp doing those Air Force tests where he was putting himself through 30 and 40 Gs. It would be something like that, and it wouldn't be a good situation. What do you get? Sasha, what'd you get? It's in the 900s. Okay. You're going to get 900 and something. What'd you get, Sydney? 972? Is that rounded off properly? Okay. Just shy of a kilometer. And again, from what I've seen of drag racing, I'm okay with that. It does take them a while to come to a stop. It takes them longer to stop than it does to get going really fast. I'm guessing because they don't want to damage the equipment and all that stuff, right? So ballpark figure, that seems gut instinct to me to be okay. Get it second time through? Yeah? Okay. Typo the first time through? Yeah.
Would not 12 be technically correct considering the way the question was worded?
How long does it have to travel before it comes to a stop? If you wrote that on first of all, if I gave this to you on a quiz or a test, that is on me because I'm very fussy on wording on quizzes and tests. And if you wrote 12 and you lawyered with me like you just did right now saying that's technically correct because there's no way from that second sentence to imply distance, yes. Now if I said something like give your answer to the nearest meter or something in bracket, then I'd argue with you. But yeah. You shouldn't find that on a quiz or a test though. That I would have weeded out. Example 3. We're going to finish with this. An object starts at rest and accelerates east at a constant rate. When it has traveled 10 meters, it's moving at speed v. How fast will it be moving when it has traveled 20 meters? Select the best answer. This year, Zach, you're going to find fairly often I will be giving you physics questions with no numbers. And I call these using principles of physics right to explain questions because almost always somewhere in the instructions it'll say using principles of physics or appropriate principles of physics. There's going to be one of these on every test. What? Yeah, but don't freak out. We'll start out with easier ones and we'll gradually build more and more. Really what I'm talking about, Sarah, is the concept of doing a proof. And eventually, I would love to move all of you into the promised land of lovely algebraic, generic proofs. They're beautiful. But for now, one valid strategy is you can always make up reasonable numbers and just crunch the numbers. And I'll walk you through a proof in a second. But first, Darcy, are there 4 choices? This means we get to vote. Once again, this is for Alex. How high you hold your hand up is how sure you are of the answer. I'm positive. I'm pretty sure. I'm only voting, Mr. Do It, because you're making me guess, and you'll make fun of me if I don't guess. And I will make fun of you if you don't guess. Positive. Pretty sure. I'm just guessing. That's okay. So let me again phrase this for you. Here's what it says. An object starts at rest and accelerates east at a constant rate. When it's traveled 10 meters, it's going v fast. When it's gone twice as far, 20 meters, is its new speed A, same as before? B, more than twice as fast as before? C, exactly twice as fast as before? Or D, faster, but not quite twice as fast as before, less than twice as fast? Those are your options. Now's the time to vote. Who says A, Mr. Dewick? A. 1, 2, 3, 4, 5, 6, 7, 8, 9. Luke, you did this. Okay. Because I've seen all those tricks before. Right? Who says B, more than twice as fast? No one. Who says exactly twice as fast? Reese, yes or no? No? Okay. 1, 2, 3, 4, 5, 6, 7. Who says D, faster but not twice as fast? Less than that. 1, 2, 3, 4, 5. This is a pretty good question. You can see we got a good spread. What did you vote?
A.
You voted A? Okay. As always, you can either attack someone else's answer as that must be wrong, or you can defend your own answer as I must be right. Before we go on to our proof, convince me, attack or defend. Can anybody? Yeah.
Constant rate.
Sorry?
Constant acceleration.
Constant acceleration, so what does that mean? Which are you saying that one answer has to be wrong or which answer has to be right? I agree there's a constant acceleration, so what does that mean?
Well,
I think it means one of those answers already must be wrong.
A can't be right.
A can't be right, you're accelerating. Now, if it had said constant velocity, constant speed, yeah, but constant acceleration, that's a uniform acceleration. Your speed must be changing. So all of us are going to cross out, ha-ha, A. So it's B, C, or D. There is a lovely algebraic proof, and I'll get you there as the year progresses. But for now, strategy number 1, Darcy, is make up nice numbers. In particular, since it's a constant acceleration, we're going to make up a nice acceleration. However, when you're making up numbers, never use the number 1, because when you multiply by 1, you get the same answer, and you might spot a pattern that is not there. So don't use 1. Okay? Secondly, don't use a 10 or a 20, because those already appeared in the question. Why would I use numbers that I might confuse with other numbers? So Darcy, give me a nice acceleration, but don't use a 1, a 10, or a 20. What's a nice number for our acceleration? 15? Okay, a little unusual, but okay. Everybody, let's just write down A equals 15. Made up number, that's okay. What was VI in this question? That they don't need to tell me, that's 0. We have 2 parts to this question. We're going to first of all use a D of 10 or 20, and we're interested in V final. What I really want you to realize is there an equation that I could tackle that has an A, a VI, a D, and a VF in it? Which one, Darce? You read too much. I think I can actually just go VF squared equals 2AD. Yes? So, I'm going to put a part 1 and a part 2. Part 1, VF squared equals 2AD. Darcy, how to get rid of a squared? Now, in your suggestion then, VF is going to be the square root of 2. What did you say your acceleration was? And what's the first distance that we've traveled? What do you get? Square root of 300. It's going to be 16? No, 17. How close am I? Am I way off? 17 point what? 17.3? meters per second. Now I'd like to find VF for 20 meters. Oh, problem. Look up, look up, look up, look up, look up. Is that VF? Is that VF? I'm going to get confused. I want to be organized, but I don't want to write much. You know what? Look up. I'm going to put a subscripted 10 for 10 meters on that VF. What will I use as a little subscript for the 20 meter one? 20. And I think, Sydney, we can argue, I think that'll be fairly clear when I look back at my notes later. Still 2, same acceleration. But Darcy, what's my next distance? That's going to be the square root of 600. Ooh, that's going to be 20 point something. What do you get? 24.5? What's the correct answer? A, B, C, or... Oh, we already eliminated A. What's the correct answer? B or C or D? I heard it here. Got to be D. Yes? Faster, but not twice as fast. Darcy, see how I figured that out? Right. Twice as fast would be 34 something, something, something. It is faster, but not twice as fast. Have I convinced you here? Is that okay, Max? D. Where it says explain your answer, I'm just going to draw an arrow pointing to that's where I explained it, but you could have written that down below there. Why isn't twice as far twice as fast? Because of the square root. Because if D was not inside the square root, twice as far would be twice as fast. Because it's in the square root, square root of 2, twice as far is 1.4142 times as fast. For what it's worth. This is why, if you've been in a car, if you floor it at a constant acceleration, at the beginning, you speed up really quickly, but the further you go, you don't seem to be increasing your speed as fast. Yeah. It's a captain, obviously. You've noticed it being in a car, but there's the physics of why. What's your homework? Take-home quiz and this. Except you can cross out number 7, number 8, and number 10. So also 1, 2, 3, 4, 5, 6, and 9. I was hoping to give you 20 minutes. You got 19 minutes. I was a little bit off.